Good morning, boys and girls. This is Professor Nelson from Electronics. Today, I'm going to introduce you to a very useful tool so you can keep your soldering iron in good condition. You're probably tired of it, or you've experienced it that after a few weeks of use, your soldering iron sometimes gets damaged, and you have to replace it with a new one. Or you may also have the problem that a thin layer of carbon tends to accumulate on the tip of your soldering iron, which prevents you from soldering properly. It doesn't usually melt the tin when it has a thin layer of carbon. And the fact that the soldering iron wears out over time is due to the fact that it accumulates too much heat. And there's no way to control the temperature on this type of soldering iron. These are easy to obtain when we want to get started in this beautiful field of electronics.
Okay.
That's why I brought you this tool or device. We'll make the tool during the video. This one here will allow you to extend the life of your soldering iron by several years. No kidding. It will also allow you to preserve the shine of your soldering iron tip. This will reduce the wear of the silver coating, thus prolonging its useful life. This way you will no longer have that problem of accumulation of a thin layer of carbon or soot, which prevents them from doing their welding correctly. So, in this video, we're going to see how to make this tool. Okay, let's begin the tutorial. Okay, guys, let's proceed to assemble our equipment that will extend the useful life of our soldering iron. For that, we'll follow the following circuit. Here we can see that we have an electrical outlet with a switch. So, let's go and buy an electrical outlet with a switch, like this one here. They're much cheaper than the electrical outlets or switches we use at home. In my case, it cost me about $2, and we're going to use it for this project. Then we have a diode. You'll have to choose the diode based on several criteria, such as the space in the box you're going to use, and based on the power of the soldering iron. In this case, the equipment will be designed to be used with our soldering iron. The soldering iron we usually use doesn't exceed 60 watts. Therefore, the current consumption is much less than half an ampere. If we use a calculator and divide the 60 watts by 220 volts, which is the voltage used in my country, the result is 270 milliwatts. The first diode is the smallest. It's the 1N4007, a diode that can handle up to 1 amp maximum at 1000 volts in reverse bias. The second is the 1N5408, which can handle up to 3 amps. This one here can also work up to 1000 volts in reverse bias. So it's up to each person to choose. Sometimes it's good to have extra, and if the cabinet space allows, we can use the largest one, the 3 amp. That way, we have plenty of current. After that, we have some indicator LEDs, one green and one red, preferably in different colors. They don't have to be the same color as those two. You can choose any color. They're ordinary LEDs. These will let us know if we're working at half power, full power, or maximum power. To protect the LEDs, we'll need resistors. In this case, the resistors should preferably be greater than 100 kiloohms. The most appropriate value would be approximately 200 kiloohms or 150 kiloohms, depending on the voltage. Again, if we have 220 volts, try to use a 200 kiloohm resistor as the maximum value. This way, the current passing through it will preferably be around 1 milliamp. or slightly higher. In my case, I'll have to use two 100 kilo resistors because I don't have a 200 kilo resistor. The resistor's power can be a quarter of a watt if you use 200 kilos. But if you have a half-watt resistor, it will still work. There won't be any problem. Remember that this also depends on the cabinet space. 200 kilos for each LED, 200K, and 200K. Okay, now let's describe the circuit. The circuit works as follows. As we can see in the circuit, we have a connector that will be connected to 220 volts. From this, we will have two wires. Where the blue wire is the live wire. And if we ignore the diode for a moment, how does this circuit work? Well, we can see that the live wire goes to the switch. And when you close the switch, the live wire will pass through and reach the other hole. That is, a contact in the outlet. At the same time, it will reach the ends of the LEDs. However, the neutral wire will go directly to the other end of the outlet. Likewise, to the ends of the resistors. And when we close the switch, all we're doing is letting the current flow through so the outlet is energized. This way, both LEDs will light up. Because one is polarized with the positive side toward the live wire, and the other with the negative side toward the live wire. Keep in mind that alternating current will provide both positive and negative current. So both LEDs will operate at different times or half cycles. Now, this diode is what will allow us to extend the life of our soldering iron. How? Well, in the following way. When we open the switch, and if the live wire has a positive current at that moment, only the positive part will be able to pass through. And the negative will not be able to pass through. That is, the positive will pass through when the switch is open. When it passes through here to one of the outlet contacts, the other contact will already have the opposite polarity. Therefore, we will only have half the power. In the case of the LEDs, the only one that will light up is the one polarized in the same way as the diode. So, in this case, only the green one will light up. The red one will not light up. Only when the switch is pressed will both light up, indicating that the power is at maximum. But when you open the switch, only the green LED will be lit, indicating that we're at half power. In other words, we've converted our 60-watt soldering iron to 30 watts. This is quite advantageous since our soldering iron will no longer overheat, and therefore the silver tip will last longer. In this way, we'll reduce corrosion and oxidation on our soldering iron. Very good. Now, based on this explanation, we are going to proceed to build the circuit in our outlet with switch. However, keep the following in mind. When we plug our tool into the outlet, it will work directly. Therefore, we need a way to completely turn it off, so we don't have to keep plugging and unplugging our tool. So, for that, we're going to use this 2-pin switch, which is rated at 6 amps. We're going to place it on one side of our outlet, since we don't have enough space up here. So, with that clarification, let's proceed with the assembly. But don't forget that what we're going to assemble is based on this circuit. And the switch, this one here, we're going to place right here, and with that, we'll open and close the circuit. So, let's begin the assembly. Alright guys, once we finish assembling our tool, we'll have to test it with the multimeter. Set the multimeter to continuity. And we're going to test our plug for safety. For that, we're going to test the plug pins. Just like that. There shouldn't be any noise. Everything's fine. We press the switch, and there shouldn't be any noise either. And everything's fine. Perfect. Now we'll plug it into the outlet. Okay guys, now once you've finished assembling our device, let's see how it works. And as you can see, the green LED is on. In this case, I can't see that blinking. It's blinking there, and I can't see it. That's because of the camera. This indicates half power, and when I press the switch, it goes to full power. And again, the red LED is blinking, which I can't see. It's because of the camera. Okay, so full power. Half power. Now, to test this, we're going to use the multimeter. The multimeter is set to AC voltage at maximum capacity. We put the multimeter leads into the outlet. And there we can see that I have 124 volts. I press the input. I go to 220 volts. I open the switch. I go to 120 volts. I close the switch. Switching to 220 volts. Okay, the device is working. Now all we need is this switch. We'll place this switch on the side to turn our device on and off. Okay, let's move that. Guys, before we put the switch in, let's see how the light bulb works. You can see that it's at half power. Let's cover the light bulb for a moment. We're going to put it at full power. We're at full power, and you can see the red LED lit. We're going to go to half power. Now let's put the switch in. Okay guys, don't forget that we're going to put the switch in here. We're going to put it right there. We're going to interrupt the power that goes directly to the socket, and we're going to pass it through the switch. Okay guys, now to finish, once you've put the switch in on the side, right here, let's test it again with the multimeter. And as you can see, there's 0 volts, nothing. And the LED is off, the green LED. The red LED doesn't turn on either. I press this, and nothing happens. Neither does it. I press the one on the side. There we have 120 volts. And we have the green LED flashing. We press the switch, increasing the voltage. We press it again and lower it to half. I press the one on the back. And 0 volts. Ready? This way you can use it to control your soldering iron. This way the soldering iron won't get damaged, so it will last longer. Okay guys, this ends the video. You plug in your soldering iron. And you can work at full power. Or at half power. Or turn off the equipment and your soldering iron. Turn it on. Half power. And full power. It's quite small and handy, and you can place it in a corner of your workshop. This way we can start soldering all the components we need to solder. Okay guys, I hope you liked the video. And if you did, a like helps the channel a lot. See you in the next video. Bye-bye.